So in the previous videos, we've defined these concepts of domain and range, and we've only been looking at things in an algebraic point of view where our function is given by its equation. And what we've seen is that figuring out the domain can get really hard. Right? There's two rules that we have to consider. We have to make sure we don't divide by 0 and we don't take the square root of a negative number. For our purposes in this class, at this point, those are the only two we have to worry about. And we started out by considering cases where there are numbers that make us divide by 0, and those examples weren't too bad, although learning how to write things in interval notation was a bit of a challenge. But then we saw some examples where we had to make sure we did not take the square root of a negative number, and that got really hard because to ensure against taking the square root of a negative number, you have to solve inequalities. And solving inequalities is this little corner of mathematics that can get really hard really quick. The best answer that I can give you for how to always solve inequalities involves using a sign line like we did in the previous video. But as you saw in that video, it's pretty hard and I need to kind of pick my battles. So don't expect me to test you upon problems where you'd have to use a sign line, although it is a good skill to have. In this video, what I want to do is kind of test your knowledge by giving you the hardest problems I can come up with that would be appropriate for our class. So what we're going to do is we're going to combine each of our two domain rules. We're going to make sure that we don't divide by 0 and we don't take the square root of a negative number. So because of the nature of this function being kind of complicated, both these things come into play here. But we'll just take them one at a time. First, we got to make sure we don't divide by 0. Why do we have to guard against that? Because we have division going on in this function. We're dividing by something. What are we dividing by? Well, it's the square root of x minus 5. Earlier, we saw examples of functions that had division in them, and what we did is we set the denominator equal to 0 and just solve that equality. Turns out that's all we have to do down here. I take the denominator, which is the square root of x minus 5, and I set that equal to 0 and I solve this equality. We want to get this x all by itself, so maybe first we'll get rid of this square root sign. The way you get rid of the square root sign is you square both sides of the equation. So on this side I just have an x minus 5, and on this side I would have 0 squared. But 0 squared is just equal to 0. And now I just add 5 to both sides of the equation, and I get x equals 5. Oh, so 5's your answer? No. I'm trying to figure out the domain. The number 5 is not in my domain. Kind of weird that the solution is actually what's not part of the answer later on. But we're not done at this stage. Excluding 5 from the domain just makes sure that we don't divide by 0. But that's not the only thing that can go wrong. There are values of x that will cause us to take the square root of a negative number. Which values? Anything that makes x minus 5 less than 0. In other words, we need x minus 5 to be greater than or equal to 0. The thing that's underneath the radical, which just coincidentally ends up being in the denominator here, but that doesn't matter for this purpose. For this purpose, it's just whatever's underneath the radical has to be greater than or equal to 0. Fortunately, this is a pretty easy inequality to solve. We don't need sign lines or anything advanced like that. Just add 5 to both sides and get x is greater than or equal to 5. Wait, so I have two different answers. Which one's my answer? Well, really neither of them. The idea is we need x to be greater than or equal to 5, but we also need x to not be equal to 5 because 5 is not in the domain. So if you think about the picture, from the stuff in green, we would include 5 and everything that's greater than it. But then from the stuff in red, we're told to exclude 5, so we don't want the 5 to be in here. So here's kind of a picture of what our answer looks like. How do you write that in interval notation? Well, I want everything greater than 5, so everything from 5 up to infinity. I always put parentheses on infinities, and in this case, I do not want to include 5, so I'm going to put parentheses here instead of brackets. For the sake of repetition, let's do two more. Here's another function that kind of looks similar to this one. We're again going to have to worry about both rules. We're going to have to make sure that x minus 10 does not equal 0. If we solve this equation, we get that x equals 10. So 10 is not in the domain. But we also have to make sure that whatever is underneath the radical is not negative. So we need the x minus 5 that's underneath this square root sign to be greater than or equal to 0. We've already solved this inequality. Gives us that x is greater than or equal to 5. So now we want to incorporate both of these pieces of information into our answer. So I'll start by drawing our number line. Here's 5, here's 10, kind of the two relevant numbers for our answers. We don't want 10 to be part of our answer, but we do want everything that is equal to 5 or greater than 5, except for that 10 which gets excluded. So if I'm drawing my picture, maybe I should have made this open circle in red. This picture represents the domain of this function here. How do I write this in interval notation? Well, there's two different intervals. There's all the numbers from 5 up to 10, and then there's all the numbers from 10 up to positive infinity. Let's see, I want to include 5, but not 10, so I'm going to put brackets here and parentheses here. I don't want to include 10, and I never include infinities, so I'm going to put parentheses on both sides here. And since I have two different intervals, I join them together with a capital U, my union symbol. How about one more of these really complex examples? If you can do this, you're an expert on this stuff and you've picked up the hardest possible questions that I can make. If you stare at this function, it would be nice if you could see that both rules are applicable. We got to make sure we don't divide by 0. What would cause us to divide by 0? Well, if x squared minus 36 were equal to 0, we'd divide by 0. We also have to make sure that we don't take the square root of a negative number. We have to make sure that what's underneath this radical, x minus 10 in this case, is not negative. In other words, is greater than or equal to 0. If we can work out the red and work out the green, we'll be able to draw our picture and we'll be able to state our answer. First, let's solve this one. There's at least two different ways you can solve this. One way you can solve this, as we saw in the sine line video, is you can recognize that this is a difference of squares. So it's going to factor as x plus 6 times x minus 6 equals 0. You could try foiling this back out and making sure that gets you back up here to understand how you're able to go from one step to the other. But another way you can solve it is just add 36 to both sides of the equation. So you can either go this way or this way. I don't really care which way you do, but I guess I'd kind of like it if you could do it either way. Over here, I got something times something equals 0. So either x plus 6 equals 0 or x minus 6 equals 0. So I got two solutions, one at negative 6 and one at positive 6. And what you see is if I take the square root of both sides of the equation here, and I remember that anytime I take the square root of both sides of an equation, I got to put in a plus or minus. Since the square root of 36 is just equal to 6, I get the same answers on this side that I got over here, plus or minus 6. Before I solve this inequality, I want to do something that teachers do sometimes that's really annoying. I want to change the problem. I think it'll be more illustrative if I make this x plus 10. So if I pretend that this original question had an x plus 10 right here. So hopefully you're okay with me making that little change. Now I go and solve this inequality, and it's no more interesting than the inequalities that we solved up here. All I got to do is subtract 10 from both sides, and I get that x is greater than or equal to negative 10. So from the green, x has to be greater than or equal to negative 10, but from the red, x cannot be equal to positive 6 nor negative 6. So how do I incorporate all that information? Well, maybe I could draw a picture. Here's my number line, here's negative 10, here's negative 6, here's positive 6, somewhere way the heck out here. I want all of the numbers that are greater than or equal to negative 10. So I want to include this negative 10 right here and everything to the right of it. But be careful, when we get to negative 6, we don't want to include that point, nor will we want to include positive 6, because the red has caused us to exclude those two values. So all the numbers in between negative 6 and positive 6 are totally fine. All the numbers greater than positive 6 are totally fine. It's just negative 6, positive 6, and numbers that are less than 10 that we have to worry about. Here's a picture of my answer, which is pretty good. If this is a test and you're looking for partial credit, that's great. But if you want to state this in interval notation, which is what I'm going to ask you to do on the test, you'll have to be able to say that we're including all numbers from negative 10 up to negative 6, and also all of the numbers from negative 6 to positive 6, and also all of the numbers from 6 to positive infinity, the numbers that are greater than 6. And then you'd be like, and I do want to include negative 10, but I do not want to include negative 6, so I got brackets on this side and parentheses on this side. I don't want to include negative 6 nor positive 6, so I got parentheses on both sides. I don't want to include positive 6, and I never include infinities, so I got parentheses on both sides. Got these three different intervals. I join them together with U's for the union system, and I have my answer to the question that's about as hard as I can make these questions, the domain of this function h.